Still drinking friends on Friday. I'm actually not. I'm just singing a Morgan Wallen lyric, folks. Awesome. I'm learning Python on a Tuesday is what I'm doing. So guys, we're going to cover dictionaries today. Yesterday, fun day. The episode turned up at the end there. We were cooking a little bit of bacon in the skillet yesterday. I was having a great time. Again, this is probably my least viewed series, but I love it the most. It's something that I've really wanted to dive into the depths of Python, and being able to do that is just, it's sweet. You know what I mean? People tune out all the time. They're like, "Hey man, not for me. Hey, not for you. I get it, but it's for me. It is for me." So that's the fun part. Okay, so dictionaries in Python, also objects in JavaScript. They store data values in key value pairs. Dictionaries are a great way to store groups of information. So if I want to define a car, this is the object of what a car, or a dictionary of what a car could look like. We have our little curly brackets, and then we can repeat and make mini cars. So let's see. Complete the get character record. That takes a character name, server level rank, and as individual inputs, and returns them as a dictionary of the following keys. Each key should map to the corresponding deal, except the ID. The ID key maps, what is it? The ID field should be set to, okay, cool. I recommend, let's see. So before we read all this, we'll reread this in a sec. I just want to describe what a object is, or a dictionary. So we could say const, or actually we're in Python, excuse me, we don't need to say const. That's some JavaScript TypeScript stuff. What the heck is that? What the heck is that? So we could define whatever object of a thing we want. So let's say we're building an object. Ignore the function and everything around here, right? But let's say we're building an object of like college majors, right, or something like that, right? So whatever it might be, right? You could say like clothing brands, right? Whatever variable you want to describe. So college majors, clothing brands, whatever. We can do an array of these things, or a list. And within this list, we can have objects, right? And these objects, these curly brackets, if you will, we could have clothing brands. And on the left side, we could say the name is like one key thing that you could just call a clothing brand, right? Like Nike. But this key is a key, right? So we can call this whatever we want. We can say it's a name. We could say it's the brand name, right? What we describe it as is only relevant to how we want to access that data. So for this clothing brand, we have Nike, right? But let's say we want to build another one, right? Another clothing brand, and we'll rename it. So the key stays the same, but the value can change. So we have Nike, maybe this one's Gap, right? And then maybe we have like Adidas, right? Just kind of clothing brands, right? And then I don't know, what's like another clothing brand? I'm wearing Pi joggers. These are like Amazon's basics, basically. Amazon Basics brand. So does this make sense that the key is like how we're going to describe stuff? And you can add whatever you want as the key, right? As long as it's relevant to the data, and you can name the key whatever you want. So this is where engineering becomes very subjective, but we can also say like location, right? Maybe it's not clothing brands that we're describing, but maybe we're describing stores or something like that. And maybe it's at like some mall in Texas, right? That happens to be where I live. And yeah, so we can add that location bit to and then maybe this will be like another mall in Texas, right? I don't know the actual address of these things, but 123 Mall Street, and so on and so forth. And this one would be 124 Mall Street. But the point I'm trying to get at is the keys stay the same, but the data on the right side of it can change. So that's kind of what we're getting at here. In all we're building is just one individual object, or one individual dictionary. So instead of a list of stores, we could just say a store might look like this. That's all they're asking us to do. But the biggest thing I wanted to teach out of all this was just how the keys and data can work. So, and I think the key value makes more sense in context of more objects, because you can like, oh, okay, the brand name stays the same, but the data changes, the value changes. So I hope that kind of makes sense. But anyway, let's get back to the example. See what we can do. Da 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 da. Okay, so we have defined get character record. Let's see what they want us to do. Each key should map over its corresponding input except for the ID key. The ID key maps to the name and the server input. Cool. Okay, so we can't have, with a hashtag in the middle for uniqueness, we can't have two Blood Warrior 123s on the same server. Sweet. For example, okay, so then the ID field should be, so, let's see. It takes a character's name, and returns a dictionary with the following keys. So I'm a little bit concerned on how we're going to do this way. Do we just say return like this, right? So the following key, actually it looks like they just want name, the actual name here. We can give it the name variable. So the key will be always the same name, but then the second name should be the one that's passed in. And we can actually do this usually in shorthand syntax. This means the same thing of having the key and the value on the right side. We can go like this, and this would actually describe both, or should describe both. And let's see. So we'll try that for all of these and see what we get. See what we get when we run the code. We should at least have something, right? Set object is not subscriptable. Pourquoi? What do you mean? What do you mean? And then it looks like the ID is supposed to be a name plus a hashtag plus the server. That's what the ID they wanted. So let's see how this all pieces together. They did say use F string, so I'm a little confused on Python syntax on how it should be, but let's try to figure it out. So then the ID field should be set to Blood Warrior. We recommend using an F string. Okay, so then we say, oh, sweet. Okay, so you could just put in F strings like this. Cool. Okay, cool. So that to me seems like what we're supposed to be doing, right? Maybe we can print this. So we'll say character. Character is this, and let's print the character. See what we have, guys. See what we got. Character, right? All right, we'll try to plug it in. Maybe I can't do that syntax here in Python, but let's try something else. Okay, looks like we have Blood Warrior server 1. So test case 1. What did we get? Here is the character. I want to see the output that we have. Boom, right here. This is the output we have. So we have ID is Franzi Boy. Looks like we're doing something right, kind of. Built-in ID function right here. And we have the name. Oh, okay, so we need to make that the name, it looks like. Server, level, rank. Let's try that. Sweet, name. That looks about appropriate, right? We'll do the same for the ID. And I think we just need to return that now, right? Pass, sweet. Okay, so does that, I hope that kind of makes sense, where the ID is sticking to be the string of ID, but then the ID will always be different from the data we pass into this function, and then the same with the name. It'll always be the string of this name, and then we're just returning that. So hopefully that all works in conjunction a bit with the talk that we had just a moment ago. And we're level 16! Woo, 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 woo. Okay, so duplicate keys. Because dictionaries rely on unique keys, you can't have two of the same key in the same dictionary. If you try to use the same key twice, the first value will simply be overwritten. So this value will be overwritten. Another developer on our team has introduced a bug with duplicate keys where the ID is the... Okay, so let's see. We got very many duplicate keys. So where the ID is the same and the server concatenated together with a hashtag in the middle for the uniqueness, we can't have two Blood Warriors with the same thing. So let's just get rid of these. And I think that fixes it. Sweet. Accessing dictionary key values. Dictionaries elements must be accessible in code somehow, otherwise they wouldn't be very useful. That makes sense. So this is one way to access them, which kind of brackets squares. So if we want to access them, we say the object, right? The object thing, and then looks like you do the brackets here, or we should maybe be able to do the dot syntax as well. We'll mess around. We'll see what we can do. But okay, so setting dictionary values. You don't need to create dictionaries with values already inside. It is common to create a blank dictionary, then populate it later using dynamic values. The syntax is the same as getting data out of a key. Just use the assignment operator to get the key value. Okay, so boom. Oh, here we go. Let's see. Names dict. So here we update the dictionary. What is it trying to do? Setting the dictionary value so I can reset. So what is it doing here? It's saying names of the dictionary. I'm setting the first names list to the second object, to Jill McCartney. I'm a little bit unsure on how this is kind of doing the deal here. Oh, I see. For every name. Okay, I see. So it's splitting the name and it's making the first name the key and the second name the value. Okay, that's what's going on. Okay. So it's looping through this names array, splitting the names array. So then at this point we have a string of Jack and Bronson as two separate strings of Jack and Bronson, and then it's taking the first bit and assigning it to the second bit. So then we get the key of Jack, or excuse me, within the dictionary, it's taking the first string and assigning it to the second string. So within the dictionary, that's the important part, is where we have to have a dictionary declared or an object declared. We're splitting the name. Maybe this will make sense in a sec, but that seems to be what's going on. Okay, so which is the correct syntax to create a new key value pair in an existing dictionary? Let's see. I believe this one, dictionary key assigned to the value. Woohoo! So updating dictionary key values. If you try to set the value of a key that already exists, you'll end up updating the value of that key. So if we do the same thing, let's see, in this example, Denver overwrote Bronson in the key. Where are we overriding? So we're doing the same deal. It looks like we're saying full names and names. We're splitting the full names to get the first name and the second name. So they get split into two strings. So we have Jack and Bronson as one pair of two strings. Then he's taken the names, the first name, the Jack, and then associating it to the second name. But why is it overwritten as Denver here? Oh, because the first name's the same, Jack and Jack. That's why. Okay, so the key is being assigned on the left side as Jack 2 times. So we're still doing the same thing. We're running through the dictionary, and the dictionary is being assessed as Jack and Bronson first as the first key value pair, and then we have a James and McCartney as the second key value pair, but then we have a Jack. So it goes to Jack again as the first thing, and it overwrites it with Denver. So what happens if you assign a new value to it gets overwrote the key and value? The value updates. That's what we want. Deleting dictionary values. You can delete existing keys with the del keywords. Okay. So what happens if you use a del, that keyword that doesn't exist? Notice if you try to delete something that doesn't exist, you'll get an error. Sweet. Okay, so counting practice, checking for existence. If you're unsure whether or not a key exists in a dictionary, use the in keyword. So we could say Ford in cars to see if that is there. GMC in cars. Cool. It's not there because it's not in our object here. Assignment. We need to be able to report to our players how many enemies that are immediate in their immediate vicinity. So, but they want to count the enemy by its kind. Complete the count enemies function. It takes a list of enemies with an input. It should return a dictionary where the keys are all the enemies' names. Where the keys are all the enemy names from the list, and the values are the counts of how many. Okay, so we need to count how many enemy names there are. So first, let's print the enemy names. Let's see what we got going on here. So it looks like we have 2 jackals. So we need to build this basically. We need to. So what did we learn in the last one? We had 4 enemy. How do you spell enemy? It's literally right there. 4 enemy. In enemy names. So we also need to build a dictionary. So we'll say enemy count or something, or enemy dictionary, I guess. Fair enough. Enemy memory, enemies in vicinity. Basically name it something relevant to enemies data. Enemies in vicinity. I'll go with that. Sounds proper. Vicinity. Okay. And basically enemies in vicinity, we need to potentially, I don't think we need to do any splitting. So we just need to count how many enemies are in the vicinity. So we're going to set it to, really what we're doing is adding a set here. Enemies in vicinity with the enemy, right? So how are we going to count this up? We basically need to count how many enemies are in the vicinity. So enemies in vicinity, we'll assign this to 0, to the 0th deal. Let's see real quick. So each enemy should have a 0 tag now on it. So we've appended it to 0. So Jackal has 0, Kobold has 0. And basically what we need to do is, I guess we'll assign it to 1. So we know if there's an enemy in the vicinity, we put it in the dictionary. This is what this is doing. It's saying, hey, here's our dictionary. put this key in the dictionary and assign it to the value of 1 because we know there's 1 there. But then we need to count. If the enemy in the dictionary already exists, we need to increment. So how do we do that? If enemies in vicinity, would that do it? If enemies in vicinity, maybe this is what we need. If enemy in here, boom. I think that's exactly what we need to do, right? We say plus equals this, else increment, right? Something like that. And then all we need to do is return. Let's see if this is working. Okay. Oh, we need to remove this. If enemy is in enemy vicinity, return that. Okay, cool, sweet. Guys, that kind of worked. That worked. So if the enemy is in our dictionary, in our set, we need to increment the count. Meaning it's already in there. We know it's in there. Else we're going to do the first thing, which is append it. So let's break it back down to this bit of logic real quick. So for the enemy and enemy names, we're breaking down each enemy name, saying, okay, we have jackals, we have kobolds, and we have another jackal, right? That's just the array we're passed with. But basically, we have enemy type A, enemy type B, and then we have enemy type A again. But if it was A, B, C, D, this would still work the same. But right now, the first array being passed in is A, B, A, if you will. Think of it that pattern. So we're just mapping, or we're looping through. We need the A enemy, we need the B enemy, and we need the A enemy again. And first, we're assigning that into the dictionary. So enemies in the vicinity that we've just made this one up. We can label this whatever we want. But enemies in vicinity, we could call it enemy data, if you will. We could also do that. That works too. So if there's an enemy in enemy names, make this part of our array or part of our dictionary. So put enemy data with the key value of that enemy name. So enemy A with the value 1, enemy B with the value 1, enemy A again with the value 1, but it just overwrites the first one. So that's the first bit of logic. And the second bit of logic that we've now added is just an if-else statement. So this if statement is already assuming if the enemy is already in our object. That's all we're doing. If the enemy already exists, find the enemy in that object, in the enemy. I'll rename this to enemy object, just so we can kind of enemies in vicinity kind of make it a little bit too convoluted. But okay, so if the enemy is already in our object, just increment the count. We need to count it. So there's a second one, right? Else, and if it's not in our object, check this. If it's not there, append it to be there. So that else statement is our instantiating it, and then the statement here, because it's weird to think about hash maps that way. So I just wanted to break it down a little bit because it's like almost inverse order logic. You would think we would check to see if an enemy exists first, and then if it doesn't exist, append it in there. But really, what we're doing first is actually checking if it already exists in our dictionary, and then if it does exist, go ahead and increment the count, else append it there. So it's a bit cheeky, but okay. So let's move on. So iterating over a dictionary in Python. So sweet, that's how to iterate over a dictionary in Python. Assignment, we need to, well, let's see. That is how to, oh, sweet, okay. So we need to display on our player's screen what the most common enemy in a given area of the map is. Complete the get most common enemy function by iterating over all the enemies and returning only the name of the enemy with the highest count. If there are no enemies, return none. So enemy dict is a dictionary of name to count. Tip, negative infinity. Okay, so we'll start with the max so far. Looks like we're going to have to play with that. So let's see. So what we need to do is iterate all over the enemy's dictionary and returning only the name of the enemy with the highest count. If there are no enemies, return none. So for enemy, we'll try this again. For enemy and enemy's dictionary. How do we map over? We need boom this. So we'll say count. This is the bit of logic we need. So we'll say count is the enemy's dictionary with the enemy. So this should return the count of enemies. And what we want to do, if count is greater than max so far, the new max so far is the count. We're reassigning the max so far variable. Else return none, right? I suppose else return none, or you know what? I think that's all we need to do is just that, then return max so far. Else return none. I think. Oh, we can't. What about this? No. Okay. Let's see what we got. Expecting gremlin. Oh, I see. I see. So that's actually returning the number. We don't want to return the number. We need to return the key with the number. So if count is this, but we actually need to maybe assign a piece of memory that's like the highest key or something, like the highest or the enemy with the most count. And I think this will be instantiated as an empty string at first, and then we need to count of the enemies with the largest count. So if the count is greater than the max so far, we need to do this. And then also we need to append, I believe, the enemy's dictionary. We need the enemy basically with the largest count with this. So I don't know if we could just do the enemy here. Let's see. Let's see. Sweet. We can. Alrighty. That worked great. So what it is taking now the string value. We're using the max so far to make sure that we're iterating the highest count, I think. Let's see if that breaks it. No, okay, that does break it. So we do need the max so far to make sure we're keeping track. Hold on, let me actually print maybe the count, I suppose, and then we can also print the enemy. Okay, so this will be the count of the enemies, and this will be the enemies. I think this is where it's getting a little bit more challenging, definitely for me at least. So basically, we check the dictionary. Hey, here's this object of data, right? We have an enemy of a jackal, we have a kobold, a soldier, and a gremlin, right? With their values associated to it. So we have a 1, a 3, a 2, and a 5. We're looping through the object, and then we're checking who's got the highest number, the 1, the 2, the 3, or 5. Okay, let's find that 5. Or through each loop, we're gonna loop through. Is 1 greater than the max so far? Well, the max so far is negative infinity. So yes, the max so far is now reassigned to the new count, and that new count is being reassigned to the correct, or not the new count, but the enemy with the most count is now being assigned as well because we know it has the largest count. And then we do it with the next one. Okay, so the kobold, now we're looping through the kobold. Okay, so the kobold, first check if the kobold's count is larger than the new max so far, which is 1. So the kobold says, okay, 3 is bigger than 1. So let's reassign the new max is now 3, and the new enemy with the most count is now the kobold. So it's a brute force approach. And then it does the next one, the soldier. Okay, let's loop through with the soldier. Well, is the soldier, let's find the value for the soldier. It's 2. Is it larger than the max so far? It's not larger than the max so far. So it's not even printing. You can see that here. So we start with the 1, and then we go to the 3, but we skip the 2. You can see there's no 2. There's no soldier with 2 here. And this is why, because it's not greater than the 3. So we're going through the array linearly. And then with the gremlin, we finally get to the gremlin, which does have a higher count than 3. It has a count of 5. So the 5 is larger than the max so far, which is 3. So then the new max so far gets appended to be 5, and then the enemy with the most count gets appended to be the gremlin. So that's how this is working. I guarantee there's a better way to do it, but it's working for us now. Let's see their solution maybe. Let's at least, oh, okay, that didn't work. Well, let's see their solution then. Most common is none. Oh, I see. So we need to start with none. This is what it looks like. That's the part we missed. Okay, sweet. So, but it looks like they have the same logic, which is awesome. That's pretty cool. Not too shabby. Not too shabby. Okay, so ordered or unordered. As of Python 3.6, dictionaries are ordered, and Python 3.6 dictionaries are unordered. Because dictionaries are ordered, the items have defined order, and that order will not change. Unordered means that the items used to not have a defined order, so you couldn't refer to an item by using an index, meaning they just existed in this object as an ethos of data. They just would float around, basically. The takeaway is if you're using 3.7 or later, you'll be able to iterate over dictionaries in the same order every time. Wait a sec. Oh, Python dictionaries before 3.7. I thought it just said 3.7 are ordered, and then we got it wrong. I was like, wait, what? What do you mean? I just said they're ordered. My brain. Okay, so check grade. A local college is having trouble with its students' administration program. They have asked you to help them print a student's grade English 1010 class. Here's the student dictionary. So this is the bit of data we get. Fun, challenge. Complete the get English grade function. It accepts a student nested dictionary. So we have all this data and returns the student's grade in English 1010. So we need to get to this piece of data here. So what we can do is say student dot. So we have return. Well, let's print the thing real quick. Let's see what piece of data we're given. But this is regularly how handling data goes. is being passed a huge thing. So we need to do student.type, right? Let's see. That should print something. Can you not do this in Python? Student dot, is that not a thing? Guys, I'm not gonna lie. In JavaScript, it's just, you just do the dot thing. You just say student.type.student. Whatever piece of, like in this scope, I'd say student.type.student.name, or excuse me, .courses, .english 1010, and we'd have it right on the money. So are we past the student object from here? So if I say student.name, will that work? Is that why? Dictionary has no, okay, so what are we given? So funny. Chester was just telling me too how there's no conditional. We went to grab sushi this last weekend. He's a brilliant backend engineer for those unaware. But we went and grabbed lunch. He's like, there's because they're doing this huge thing at Babson for this lab report and just lab data. And he's like, there's no ternary operators for Python. He's like, it's the most frustrating thing in the world. Or not ternary, but conditional type operators. Okay, so I honestly don't know how to access this. Let's see, what are we missing here? This shouldn't it just be oh, you know what? Can we do this? That's how we do it. Okay, so student.type. Can I just keep going? Sweet. Then we need student. Okay. Courses. Now we have access to all the courses, and we just need to return the English 1010 one, and that, folks, is our answer. Sweet. Or should be. Oh, and we need the current grade. Forgot it. Pass. That's right. Level 16 wizard, folks. Come on now. Who are you messing with? Don't mess with me. Don't play with me. Okay, total score. A website that tracks basketball scores and stats is having trouble with its data. The first half and the second half score data are stored in separate dictionaries, making it difficult for them to parse the overall score. They have asked you to help them write a program that merges the two dictionaries together and calculates the total score. Ooh, this is teaching us some merge sort stuff early on. That's brilliant. They're brilliant at boot.dev. They are brilliant. I will tell you, this is a brilliant course, how they've organized it. Complete the merge and total score functions. The merge function accepts two dictionaries and returns a single merge dictionary that contains all the keys and values from the input dictionaries. The total score function should take a single dictionary as input and return the total score calculated as the values of that dictionary. Take a look at the test suite near the top of the file. We gotta sneeze. Woo! Okay, the function should return 0. Don't forget you can always add print statements. Okay, sweet. So let's just kind of figure out what we need to do. Okay, so first I think we're gonna have to call this function in the total score function. Let's see what we're given first. So I think one of these is called, the other one isn't. Here, and let's say here 2 or ear 2. Yeah, so in this total score we need to print the merge thing, I believe. Okay, so dictionary 1 and 2. So let's mess around with this first function first. So we have a first quarter, second quarter, third quarter, boom, boom, boom. So I think it's just as simple as return dictionary 1 plus this, right? Dictionary 1 plus this key plus dictionary 1 plus this second quarter key, right? And we just do the same thing, but with dictionary 2 plus this, right? And we need to change the thing to dictionary 2 right here. Oh, I could probably break it out to a more readable thing. So I'll say first half score equals this, and we'll say second half score equals this. And then to merge the two scores, we just, of course, add the two scores. I believe, hold on, let's run it. Let's just double check, make sure we're looking proper. 133, sweet, it's expecting 133. Okay, so we'll leave it like that, I suppose. And let's see, total score. Well, that is the total score here. So do we even need the deal? What is the second thing mean? The total score function should take a single score dictionary as an input and return the total score calculated. Oh, so I see it. It doesn't want us to do this first. It wants us to build a what's it called? So we've gone too far. We've done too much work. We need to break it across to single functions that handle business. Okay, so the first thing we need to do is just add dictionary 1 plus dictionary 2. It looks like we're gonna steal this bit of logic though for down here. I don't want to rewrite it all. So all we need to do in dictionary 1 or up here then is just return, let's see, we'll say total game equals dictionary 1 plus dictionary 2, and we'll take the total score. We'll return this total score plus the total game dictionary. We'll be a little bit more specific. So this total score receives the score dictionary. I guess to keep it congruent, we can maybe name it all the same, or I'll leave it like that. And then we take the score dictionary and basically add all these things together. So we could say total score equals this. It's just the score dictionary plus this one, plus the third quarter, plus the fourth quarter, plus the, I bet we could do this a little bit cleaner too by passing in that'll work, but I bet we can loop through so we don't have to declare all the keys like that, but this should work too, I think. Dictionary 1 plus dictionary 2, where are we at? Oh, why is this not working? Dictionary 1 plus dictionary 2. Pourquoi? Ay. Unsupported types dict. Okay, let's print these out and see what we're doing wrong real quick. What the heck? Guys, we had the answer. We had the right answer. So maybe we'll just go back, get the right answer, and we'll just return merge. Answer equals merge. Let's see. All right. So we have the answer right here. We have the answer. What does it want us to do more? I'm so confused. Okay, so we need to combine the two dictionaries. I thought if we do dict plus 1 plus dictionary 2, that would just combine the two dictionaries. So how do we combine dictionaries? We can't just add them. Okay, so that is a bummer. So we'll say for key val in dictionary 1. I see. So we need a total dictionary equals the boom for key val in dictionary 1. Can we just reassign them? Is it as easy as that? Just dictionary 1 equals this. Total dic equals dictionary 2. Oh, no, that won't work. That will not work. Okay, so for key value in dictionary 1, how does this look again? Do we get all the scores? No, we get first quarter, second quarter. Sorry guys, I'm not sure, to be honest, on how to do this, so I'm kind of just shooting from the hip here. So we have the scores being printed out. This is our answer, is adding these two together and these two together. This is literally our answer right here. So that's the frustrating part, is we do have the answer right here. But we have to do it in their specific way, it looks like, which makes sense. You know, I guarantee it's to learn the properties of merge sort. So we have expecting 133, and this is the answer right here, 133. So that is the correct deal, is adding these four things together. We just need to add them into a dictionary, or merge the dictionaries first. All right, so we're just gonna peep at their deal, because that is exactly what we need to do, is return this answer. We've done it successfully here. But yeah, I don't know how to merge the things, so let's do it. So merge dictionary, we need to 4K. So we were trickling down the right path. I'm not gonna lie, I like my code a little bit better. It's just easy, it's just straightforward, it's there. But here we'll obviously do this because this is gonna intro us to merge sort a bit. So we need to learn this, or I need to learn this specifically. I guarantee you guys are like, this is all you do. This is what you're supposed to do. Okay, so merge dictionary, boom, we have an empty object or an empty dictionary. 4K in dictionary 1, boom, we merge dictionary with, okay, cool. So we assign it to the dictionary value 1 and then return the merge dictionary. That is cool. That is swimming. And let's see, K total score. Looks like they did it a little more cheeky, so they could have unlimited frickin' quarters. It would all work. Okay, so let's try to do it. So merged dictionary, let's try to do it off of kind of somewhat warmed memory now. So for score in dictionary 1, right? We'll say merged dictionary score equals dict1 score. I believe that's what it wants. And then likewise for this one, we just need to do dictionary 2 and boom. And then we need to return the merged dictionary. And that, I believe, ooh, how did they invoke it in the other functions? The question, right? Print merge dictionary. Let's see what we got here. For score 7 years ago. What's going on? Oh, down here it's empty. Okay, so print test, boom, sweet. Okay, so we do have a merge dictionary now. Sweet, we've done it. And I believe all we need to do is return this up here. And that will, now we have access to that merge dictionary down here. So print score dictionary. And we do have access. So I'll declare it by this. And that's our deal. So we could, as seen before, we could return it. Score dictionary where we add the first quarter plus the second quarter, and that would absolutely work. Let's just double check it would work. And then what we could do is the fancy way that they did it too, because that seems to be the direction they want to teach us, and probably seems like the most programmatic way to do it. But now, why is that not working? Now that confuses me. Okay, so it looks like that absolutely will not work, and that we do need to do it the programmatic way. So let's do it. So I don't understand why that wouldn't work. I don't know if I spelled something wrong or what, but okay, let's do it. So we have score equals 0, and let's say for, ooh, this is going to be tricky. So for score in score dictionary, let's print the score. Let's see what we're working with now. What is going on? Why is it this none type? Oh, if you're given none, why? Line and total score, for score in dictionary and score dictionary. Can we just do this? Guys, this is cheeky. They've done some cheeky stuff here. This is a cheeky one. Okay, so merge dictionary, boom. Is the error happening up here, or is it happening because we're trying to print the score dictionary with an empty quarter potentially? Yeah, so it looks like it's returning none right here. So let's see. Don't forget, you can always add print statements. Boom. The function should return 0. If no points were scored, the function should return 0. Okay, so that's important. So if let's see, if score for score in score dictionary. Let's see. So why does it break there? Why does it break there? For key and this, boom, boom, boom. Let's steal this. That's what we're looking at, but we're getting 0. Type none type is not iterable. What is going on, folks? Okay, so I can't have a empty dictionary. It appears, but this is what they did. No. Okay, we're gonna have to peek at the solution. Merge dictionary. So they don't even call it down here. But how do they get this? If they must already be doing it in their doohickey. Got it. Okay. Now we're back on, folks. We're back on track. Okay, so for score in score dictionary. Let's print the score. Let's print the score at the let's see. So that would be the first quarter. Second quarter. Okay, so we do have the key from the key value, which means we can definitely say so we don't want to say score. We'll say for quarter here because we're going to call it score. So I'll say for quarter, the score equals to this score dictionary at this quarter. And let's now print the score. It should be the numbers, right? Sweet. And we could say total score equals 0 initially, and then we could just plus equals the total score to the score. And then return the total score, right? Return the total score. Mama, we made it. We made it with a little help, little assistance. Now, nothing wrong with that, but we made it. That's a bit of we're getting a little bit more heady, guys. This is kind of fun. But the cool thing is like kind of understanding of at least some of it, at least some of it. So, okay, so grocery shopping. Emma has been overspending recently and wants you to write a script. Oh, we are deep in the challenge. I didn't even realize. We're like deep in the challenges, folks. I should have known. We're about an hour in. I should have known. But this is challenge 3. We're wrapping it up here. So this is where it gets a little more fun, guys. This is where it gets a little more fun. I can't believe this is like the intro part too, which is crazy. So we're gonna be diving a bit more into more Python stuff, which I'm excited. I just want to overlook the course trajectory real quick of what we're looking at next. So we got it looks like shells and terminals, and we're back on the Python deal for a little bit more, which we have functional programming, and it looks like data structures and algorithms in front of us, a little bit of inheritance, encapsulation, and a few things like that with object-oriented programming. Then we got the JavaScript, which is my home territory. That's my hometown. That's the hometown for me. So I'm very excited. And Go, I'm super excited to learn. It's a high-level programming language. Definitely integrated heavily with many microservices nowadays. So that with SQL, we should be dialed. I've mucked around with Docker a few times, and then we'll get into some CI/CD pipelines, and then some Kubernetes and cryptography, of course. Some cryptography should be a good time. So I'm excited for it. I love this boot.dev thing, by the way. I cannot say it enough. I'm such a big fan. Okay, so grocery shopping. Emma has been overspending recently and wants you to write a script that will help her manage her finances when she's grocery shopping. Complete the calculate total function. So it looks like we need to calculate the total of all the things here. So items purchased, a list of items purchased on the shopping trip. This is a list of strings, a grocery list with the a list of the names of items Emma wanted to purchase. This is also a list of strings. Okay, so this is the, oh, I see. So she wants to see the difference of what she meant to purchase versus what she did purchase. So it's unpurchased items, a list of all the items in the grocery list that weren't found in the items purchased. Okay, so we need unpurchased items, a list of those. We need a receipt of the items purchased. So we need one thing of, so let's see. So we need return. We'll say answer one is going to be unpurchased items, right? List items not purchased, most importantly, right? Say grocery list items not purchased. Our second answer is going to be total items prices, right? Total from items prices. And then our third answer will be the total cost of all the items. That wait a second. The receipt should be the total, right? A dictionary containing all the items Emma purchased, even the stuff not on her list. These. Oh, I see. So this will just be return of this, right? A dictionary containing all the items Emma purchased, even the stuff not on her list. The keys are in the item. Oh, we just want the keys. Okay, so this is actually answer 3 is the total cost from the item prices. And answer 2 is just the list from item prices, the list of keys. Okay, so we need those 3 bits of data. I don't know where to start on each one of them, but we'll figure it out. So grocery list items not purchased. So I think we just need the keys from that. So for item, I'll say grocery list item in grocery list. Let's see, we have answer 1 will just be an empty object, and we'll say for grocery list item in grocery list. Let's print the grocery list item to see what we're working with. That's it, I think. I think we just want to assign grocery list item other way, answer 1 into grocery list item, right? Then I just want to print answer 1. Let's see. Error cannot. Okay, that's not the answer. That is not the answer. But I think this might be. No. Need a list of, oh, it needs to be a list. Okay, so we need to append answer 1 with these list items. And let's print answer 1. That should be all our list items. So I think answer 1 is done. We got the first bit done. Okay, so we'll leave it up there for now because I think that's done. And we have answer 2. We need a list of keys from items prices. So I think we need the similar deal, but it needs to be a dictionary instead of a list. So we'll steal some of this logic. Let's make answer 2 a dictionary, and that's not going to work. And I think we need it from the items purchased. So a dictionary containing all the items that Emma purchased. So let's go ahead and swap those in. So items purchased, and we'll swap it for item purchased. We'll rename it. So item purchased in items purchased. And let's just print those real quick to see what we're working with. We have all these purchased items here, and we just need to put those into our dictionary. How do we do that though? So we need similar deal. If it was similar to that one that we had with the count of of enemies, right? If there was no enemy in the dictionary, put it in the dictionary. So let's see if item purchased. So if there is no item purchased, right? We need to maybe I've got this backwards, right? So items. So in the dictionary of item purchased, right, equals item purchased. Maybe is that all we need? And then let's print answer 2 to see what we're working with. Sweet. I think that's it. So that looks about right. We have our milk, eggs, cheese. Well, hold on. There's a lot of doubles now. So answer 2, item purchased. Oh, I see. So I'm assigning the dictionary with a key value of that, but let's see if it wants that. So a dictionary containing all the items purchased, even the stuff not on our list. The keys are the items' names and the values are their respective prices. Okay, so that is going to work. That's going to be their name. And then we actually need to get their prices. So how are we going to do that again? So we need the right here. So the item purchased, the 1 value. Will that work? Nope, that will not work. Items purchased. Well, What about this? Oh, get rid of this real quick. Okay, so where is their, oh, their values are here. Okay, we're not giving them in the, okay, so let's do it here. So we'll say, is this sign, the items purchased is going to be, believe maybe this. Let's see what we got, folks. Let's see what we got. Items purchased is going to be item purchase, right? Sweet, there we go. All right, there's answer 2. So we got our answer 1, we got our answer 2. Let's get answer 3. Let's do the answer 3. So we need the total cost from the items prices. In this, we could say total, we'll just, I guess to keep it congruent with what we're doing, we'll say answer 3 equals 0. And we'll say for item price, in items prices, we can just go ahead and say answer 3 equals this, boom, item price. I think that's all. I think that's all. No, for item price. Oh, we need the key from item prices. So we'll say item prices. Let's try that. Sweet. Okay, I think that's answer 3. So we got